Either have to choke it down or chug it down. Get the windpipe dry, or yeah, de-dried. Wet my whistle. I tell you what I wanted to throw across was just some of the troubleshooting I ran into when I started early in working on tractors finally. We got out in 1980, Brockport Ford tractor, but I was the new guy assembling equipment, which was fine by me at that point. But after a while, they got me into some other repairs, tune-ups, and I think, Red Tiger Ford, I think it was a 850, 860, something like that. It's the same cover for the 600, 800, 700, 900 tractors. And I don't even think they changed the relief valve either. That's the weird thing. Same one right up through. And I did one of those and had to argue. And this was the funny thing. I learned the hard way, or actually, I learned the easy way. And I ran into a service manager that listened. He said, check it with air. I said, I don't think that's going to work. And another guy said, no, it can't work. And he says, well, we're going to check it with air anyway. So that's not going to end well. And it didn't. And it blew a seal out of a piston. And I had to stick it back in. He said, what'd you do? I said, well, everything was still there. So I took my screwdrivers and poked the seal back down in. Back then, it was still a leather backup ring with an O-ring. And went back and tested it. And I basically, after about, I think it was several hours. I mean, by the time we got done, I think we had 5 or 6 hours into something ridiculous. And he charged the customer for all of it. That's the funny part. And when I got done, I just made the basic adjustments. I said, I did this on my own tractor here a year or so ago. And I said, it worked beautiful. Or a couple of years ago. Actually, it was before I went to college. And he said, you did? I said, yeah. Well, I guess that's what we're going to go with because air isn't working. No, Bob, it wasn't. And he admitted it. That was the funny part. Well, keep trying, keep trying. It's got to work. Air's pneumatic, you know. I said, yeah, but when you stop pumping oil, it stops. I mean, the energy stops. If you build up to a certain pressure and you stop pumping, it stops. And I said, pneumatic, it just keeps it's still trying to expand. There's always the pressure never stops because you compressed it to make something move. And even if you hold it, that air is still compressed, pressing on it. And when you're working with a fluid, you stop pumping the fluid, it stops, period, unless it's in a totally confined area. But it stops at the pressure you were at. And if anything happens, any leak or anything else, all the pressure's gone instantaneously. Fluids, your average fluid, liquids anyway, they compress about 5%. And that's just a general rule. As you can guess, the higher the pressure, there's going to be more happening. But they said in general, they'd say 5%. Pneumatics, that's a whole totally different story. Completely different. I mean, just as an example, the oxygen in your tank, when you have your torch sets or your acetylene, or any of the actual gases, hydrogen gas, nitrogen, all of them, the volume changes in the same tank by the amount of pressure you put in there. Well, with hydraulics and liquids, no. You say, well, no, wait a minute. Nope, you can put more pressure on it, but once it reaches full, it's full. That's it. It's all over. The pneumatics, it's not. You can continue to fill it and raise the pressure and have more contents in there because it is gas. Well, when we worked with hydraulics on that one, we got done and the customer took it home and he came back later and he says, I wouldn't have believed you. So what do you mean? I wouldn't have believed you. He says, you told me to shut up and go home and try it. Because he argued with the service manager quite a while. And the thing is, the customer didn't know he had a point. He said, I'm a mechanic too. And Bob said, you are? Well, then what'd you bring it to us for? If you're a mechanic, why didn't you fix it yourself? You brought it here. We know what we're doing. We have it fixed. We give you a warranty. You pay your bill, take it home, and enjoy. Or something similar to that. And he did. It worked. It worked out very well. And he came back the next day and just popping up and down. It was one of the first, how can you say it? It's one of the, hijack. It was one of the first customer encounters that I had. I was a little bit nervous about it to some extent, but it worked on my tractor, so I knew it would work for him. Same style tractor, the Red Tigers. Is that Hobie? It worked out very well. So some of the other stuff I ran into was different, but I'm talking pretty much hydraulics today. I ended up moving across state from that general area. That was Brockport Ford Tractor in Holly, New York, at the former Duryea Motors, one of their original buildings down there, and it was kind of a double level. The road came around, and there was the front of the building here, but behind it, there was a kind of a cutout and a low spot down in there, and the whole village of Holly had a whole low section down in there, where there's some buildings in there, including the bank, that were 2-story, but the working part of the building looked like a single-story building. So that was an interesting place to be. When I got out of there and ended up moving across state to Cobleskill region, yeah, it's quite a ways. You go from Orleans and Monroe County and go across to Schoharie County. I was actually living in Montgomery County, and ended up at Cobleskill Welding and Alice Chalmers, a New Holland dealer. We had a 200 Alice that came in, and they couldn't figure out what was wrong with the thing. And I guess it was a test for me. I'm not sure. His steering got weak. I was playing around with it, and the steering was weak, and under certain circumstances, things would happen. And I took a look at the pump and what we had, and I grabbed one of the hydraulics for the remotes. There was nothing behind it, so it deadheaded, and I popped the relief, and all of a sudden the steering started working. I think I know what this is. I played around with a few other things, and shazam, I could get steering occasionally. So I got around to the side and looked at the pump, and there's a huge nut. I mean, like 1 3/8, but it was very thin. I got that off and reached in there and pulled out a flow divider. Cleaned it all up, cleaned up the hole, and I wasn't familiar with cleaning this stuff up. This was my first. And the main reason I did the troubleshooting on it was when I pulled the lever, I said, well, there's got to be something in there that connects the two circuits together. And I went up front, took a look at the pump. There were only 2 sections to it that I could see, 2 outlets. And I had to come surmise that, well, you know what? Actually, there were 3 outlets, but the one outlet was in a weird, odd location. And I cleaned it up. And today I'd clean it in a little different manner, but still got it all cleaned up, put it all back together, fired it up, and the steering worked. And I think I was done in about an hour. They were freaked out, especially the service manager. He was flipping out. Why? Well, he's smarter than me. He knew it. I was just a dumb little 20-something-year-old kid. 24 or 5 at the time. But hydraulics was something that I enjoyed. And that was an Alice Chalmers 200. 190 XT is similar when they have flow dividers on there. Now, what's the idea of a flow divider? Well, basically, you have one pump, one outlet to the pump itself. But in this case, it was inside the case. It came to the back of flow divider. Flow divider was a big valve, and fluid would go through the center of the valve. When the valve was poked all the way over to one side. As the fluid went through the valve, faster, more, it reached a certain rate where there's an actual back pressure. Faster the flow, the more it moved the spool. Move it again. Well, what was it doing? The primary circuit was steering. Yeah, the primary circuit was steering. So what it was doing was making sure that all the lower flow was going to the steering, the power director, and the PTO, which the PTO is just downstream as it went on. But steering had the basic priority. So everything that went through that little hole was going to steering. Faster and faster, it'd start moving the spool, and the spool had holes in it. After that, and it'd open up. Was it after or before? I think it was actually, this would start to uncover them on the back side. And the spool would move, and oil would start flowing to the back. Someplace, I think around 4 gallons a minute, and it was 3 or 4 gallons a minute was a 9 gallon a minute pump, I believe, 9 or 12. Someplace in there. I'd have to go back and check. But it would take approximately a quarter to a third of it. Make sure it went to steering first. And then once it passed that, it'd start moving the spool and open up to go back to your 3-point hitch and your remotes. They were next. I had a couple of cases where there was all steering and no remotes because the valve was stuck. It wouldn't move. So you say, well, how did it do it the other way? I said, well, it came up far enough. And I'm not exactly sure how, but it pulled it up far enough so all the fluid went to the back and you didn't have any steering. And you said, well, but both circuits are open. Yes, but both circuits are open center. It's a gear pump. That's why it's called a flow divider, because there's always flow through the thing. And it adjusts to be sure the steering gets the priority. It should be called a priority valve, but they call it a flow divider because there's always oil flowing through it. So what would happen with the 3-point and the rest of it? Well, it'd flow, it'd stick open, and all the oil will go the path of least resistance. You go to turn the wheel, well, it's open center in the back. So the oil will go out and go through the open center of your rear controls. As soon as you pulled that lever and closed that and deadheaded it, or even ran a rear hydraulic cylinder of some sort, as long as there's some resistance of flow, you'd start to feel the steering come back. And when it deadheaded, you had all the steering you could ever want. And partly because now it's operating on a relief valve in the rear. So that's what was happening with that. Now, how do you describe that? Well, get a piece of paper out and start drawing. Pump, port, flow divider. Okay? Flow divider comes in one end, right? It starts to move the spool. So oil's coming in, oil can go out another section. As a spool comes up, it opens up and goes out to the rear. But there's always coming out the end here your flow for your steering, always. The orifice is designed for that particular size and that flow rate of the pump, that as you speed your engine up, there's more flow, and then it starts to move. Then you say, but that puts pressure on the pump constantly. It does. Well, that's a problem. No, not really. A, it's designed for it. B, these had pretty good brass coated end plates, but at the same time, the pump has a little bit of pressure on it and pressure behind those plates. So in a sense, it only has, when it's in neutral, just flowing, say at half to full throttle, there's always a little bit of back pressure on it. So the pump has both lubrication and sealing pressure on it. And it tends to work a little better that way. So it's nothing that the pump can't handle. It enjoys just, a little bit of pressure here and there. Now downstream also further, when you go to your power director, I think there was 250 pounds of pressure there, 250, 275, and then further downstream was 180 psi for the PTO. So there was always pressure on that pump no matter what you did. And it was after going through the steering circuit. Even when you were at low, those two valves were closed center with a regulating valve. In the power director, I believe, handled it for both, but no, they both did have a relief. And the thing is, it's like stacking. All the way to the end is 180. Well, the back pressure between there and the other valve, sometimes they can stack each other up and boost the pressure a little bit. For the most part, there was always some back pressure on that entire system until you started the steering wheel. They say, well, yeah, but they're not open center. No, they go to a regulator, and one goes to the next. Then the next blows the relief and goes back into the transmission housing, the reservoir. I said, well, that's not open center. How do I know? Steering's still open center because it's flowing all the way through the steering motor, going to the PTO valve, or the power director valve, and then the PTO valve. The steering is always, which means it always has a couple of 100 pounds of pressure in it all the time, up to 300 psi through that whole system, no matter what the flow rate is. So the pump doesn't really care. It has its own little passage in there where it has its own back pressure that's essentially separate and used up in that area compared to anything else in the system. Because of the flow resistance to flow, it has a back pressure of its own. It sounds kind of odd, but if you keep following the circuit back, the pressure keeps going all the way up. And if you could put a gauge in there, it would be higher than the PTO. And when you start turning the steering wheel, it has its own relief. Oil goes into the steering wheel when nothing's happening, goes straight to the power director valve and PTO. When you steer the wheel, now the oil goes out, does its steering, comes back, and then goes to the PTO and the sump, unless you hit relief, which in the steering system, I think, was 15 to 1800 psi, something like that. So That was the other thing too, was that they always, no matter what happened to the pump, unless it malfunctioned in a funky manner, where your flow went to the back and you didn't develop enough to drive the tractor. If it's stuck in a particular position, well, if you wanted to drive the tractor and steer the thing, you pull your relief, you can steer it, and there's a lot of funky things that can happen with that system. So that was something I recognized when I was young and never forgot, because I probably had to free up a dozen of those valves over the years. One of them I missed and somebody else did it for me because I never had a study on it. Same system, different tractor. It was a 185 Allis-Chalmers, I think. And it's the difference here is there's no flow divider. Now there's 3 pumps. One pump for traction booster, which the 190 XT also had in the 200 Alice's. It's a little bitty thin steel section. I think it was towards the front. And then in the middle is another pump with considerably more flow that's for your steering, power director, and PTO. And there's a third pump to run your remotes, and then 3-point in the back. One of the problems we used to have on the 180s and 185s more than any other tractor was that every so often the 3-point hitch would go up and stay up, and they couldn't get it down, and sometimes you'd hear the relief. And the hydraulics and transmission occasionally would get hot. And what I didn't realize was the traction booster had an override valve. So that little bitty 3-gallon a minute pump up here, all the way in the end of the valve stack underneath, between the fender and the tractor and the seat, it was quite exposed. And the plunger would get rusted and stick because you didn't use it that much. It was often a manure spreader and loader tractor. Crap would get in there, and if somebody would move a lever and poke that little thing in there, and the little plunger would go in and it would raise. And that would override the rest of the hydraulic system when it did that. It cut off the flow to the 3-point hitch from the main pump. That's right, the main pump, okay, traction booster, steering, PTO, power director, and then the actual hydraulics in the back, the working hydraulic pump. That little one would override, so that when you made adjustments, they were slower. So when I went to raise the plow, it'd just be a nice, even lift, smoother. As you start dropping 9 gallons a minute on there, that's a lot faster than 3 or 2. They just wanted a little lift. That's all they wanted. And that would override the main system. So if you pulled the lever while you were going to raise the plows, well, it didn't matter. The traction booster took care of it. Pull the lever to change, because there's 2, your main lift and lower. Then there's one for position control and one for your draft control, traction booster. And then if you moved either one of them and got that plunger to go poke in there, which usually somebody repositioned the position control, it would stick and override, and they would stay up. So you'd have to go out and clean that up, get the spool moving again, and the tractor's happy as a clam. Now another one with the Allis-Chalmers that was an interesting thing is you pull the lever and you'd hear this click, and there's no pressure. So you check it again, you start pulling the lever, the pressure would start going up, and then click, no pressure, all gone. Well, what was it? Well, it turns out they had a pilot-operated relief valve, and when they got worn, and the seals were worn, you didn't get the differential pressure. The little poppet would start to go, and when it did, it would do its little control, but the sleeve in the outside had there was leaks, and it would unbalance easier. So it wouldn't even get you get stuck, Hobie. Get caught on a cord. And what it would do is this outer sleeve would pop and open up, and just total flow. You'd have almost zero pressure, weaving wide open. And when I figured that one out, I went back to get a valve, and the kit was like $75, $50 something. And it was $200 for the main. And then he says, what do you want to do? And I said, well, probably resealing it would be fine. But you know what? For the amount of money that's there and making 2 or 3 trips, he says, I agree with you. The parts man says, I'd take the valve out. So we took the valve out, put it in the tractor, worked beautiful. You have to remember on these tractors, though, there are 2 valves in the systems. You have to pick the right one. One is the traction booster relief, and the other one is your main system relief. I think you can swap them. And the boss made some mention about that later. And the one guy says, well, what good is that? I said, what do you mean? You got 2 old used valves. You're just going to swap them? Well, now your traction booster's worthless. He says, well, that's not my problem. You fix theirs. And the parts man says, you know, Dave, you've had this problem of fixing things right all these years. You always go for the quick fix, and then there's a problem later the customer complains about. And he was talking to the business owner. And he says, why don't you let us fix the tractor, Dave? So we did. The other part you run into is that this is one of the things where the parts that come in some of these kits, the parts a good parts man knows, they've been sitting on the shelf for a while. And what happens is the O-rings, but more than the O-rings, some of these actually have Teflon rings and nylon backup rings, and they start to get old and they do not stretch well, even under hot water conditions like I use quite often. or like one guy did, coffee. If it's hot coffee, we used to soak the stuff in. Work good. Put it on, but then you have to work it all with Teflon. You have to work it all back down. It shrinks a little, but once it's stretched, it stays stretched. So you work it all back down, and you can put it together. And we were just looking at the fact of, it's too easy for something to go wrong. These are a good customer. We don't want to screw them up. No, they don't want to pay any more, but you know what? They bought a John Deere chopper, so they've got money somewhere. We put the relief in, and it worked great. Why wouldn't you do it in the traction booster? Because that relief is rarely ever used. It just sits there. So if I had swapped it, that might have caused an opposite problem where the thing didn't open because it sat there with this fluid going through it and it hadn't been operated probably in years. That's what we were looking at. The parts man and I, was old Charlie Holmes, and I was about 25 at the time. We saw eye to eye in a lot of stuff. So it worked out pretty good, and I learned more from him than I did the bosses that have been working on this stuff for years. So that was one of my other hydraulic excursions that I've been into. The two main ones over the years when I worked with Alice Chalmers of anything else. The 7000 series rarely had hydraulic trouble. I mean, rare. The power shift tractors, the valves on the side would warp and blow a gasket out. They needed to be machined or flattened, sanded down, flat again and put together, and then they were okay. But if you didn't fix it soon enough, it started herky-jerking and chunky-chunking, you blew your clutches out, and you're going to tear the thing apart because some of the clutches won't fully disengage. Rather than running on one or two clutches, now you're on three, and it gets ugly. And this one wasn't designed with two clutches, like one was always engaged and one's coming off while another's coming on. They actually was designed for fewer huge 14-inch clutches. Huge. Things were monstrous. And just one clutch would go off and the other would come on. Why? Because they're huge. They could handle it. When it was working, beautiful. Beautiful system. But they didn't have enough filtration. And then the other part of it was they had, rather than having bleed-off holes, they actually had little bleed-off valves. Little check balls and such in them. If they'd have made the holes smaller, they would have been better off, so that just continuously drained when the clutch was engaged. But they put check balls in there with the idea of when the clutch is off, it opens up and can't develop any pressure. And when you snap it into that clutch, then the little ball would get enough oil flow that it would close it. And a lot of them, there were several balls and poppets in there, they'd get plugged and wouldn't shift properly. The idea was excellent, keeping it clean so it would continuously operate, and there was no way to service them. You had to tear it all down. So at high hours, it would have been good to change your filter often, change your fluid often, and don't slip the clutches. But that was mainly, I think that was mainly in the foot clutch. No. Yeah, there was out of 6-speed, the bottom 4 were clutches for the foot clutch, your actual inching pedal. The bottom 4. So the 5 and 6, actually you'd step on the pedal and it would bring them back into 4th every time. So that was an interesting thing there. What else was that? Oh, coolers would plug up now and then. That was another problem because the filter was mainly on return. So if you had plug cooler, cracked transmission cooler was in the bottom of the radiator. And what would that? No, they used a hydraulic cooler that way. Plus they had they put one of them in the bottom of the trying to remember. Oh, that's right. This had 3 separate pumps, and one of them was nothing more than lubrication and cooling. And the cooling went through the bottom of the radiator, plus they had a hydraulic oil cooler in another pump, and they all used the same sump. That's what was happening with that. The one in the radiator was known to crack, and it would get water in there and wipe all kinds of stuff out. So that was one of the main things there. The other one was I had 1 or 2 times that an unloading valve seal on the pump, the piston pump, broke. The spring, I should say, not seal. A spring broke. And the one case, what I did was I turned it around and put the broke side of the long piece in, and then took the flat side of the short piece against the tail. Yeah, I put the good side in, so the tail stuck out, took the little piece and turned it around so the flat side stuck against the busted tail. And then the busted tail was out here against the nut. Put the nut back in, and then developed just enough pressure so the hydraulic system could operate. You say, well, no, it was the standby, the unloader is standby pressure of about, supposed to be about 500 pounds, 400 to 500, and I had it at 350. It was just enough so that the pump could turn on. It would go over to pressure compensation. So that's how that one worked out. It's the only real hydraulic problem I ran into on those tractors. It very little otherwise. Almost a steering cylinder maybe and a hand motor. So that was something if you go back a little bit too, the steering systems on the 180s up to the 200s was rare to have any trouble. It was almost always a hand motor leak. It wasn't common even to have a cylinder leak, but occasionally one of them would leak. I mean, Alice built some incredible cylinders for their steering systems. 7000 series had a monster of a rod in it. Well, why was the rod monstrous? Well, it's for a balanced steering. When you would steer so the thing would collapse, then everything from the back side would return and go back to the system, into the system. When you went to steer the other way, because this end was so large, this smaller end would take the oil and run it into the back as a regeneration system. It didn't go back into the return to tank. It actually regenerated from that smaller diameter end. I say smaller, it was bigger in the outside diameter, but it only had a little bit of a rim that the oil was acting on. So it didn't have much oil compared to this backside. They just regenerated back in there because it was pounds per square inch on more square inches than it was on this little bitty rim on the other side. Smooth steering. Oh, people loved it. So there's a lot of good stuff that was on the tractors and the hydraulics for those. The back end was a PFC, pressure flow compensated system. And the only reason they call it that is pressure compensated as it's operating. When you put it into neutral, it drops a signal, and that little spring I was talking about was the unloader. It'll drop the pump down to 350 pounds of pressure, and that's what that one would control. And when you pulled the valve on and off, that's what actuated that little bitty valve. So it would open up the pump to pressurize the little unloader, and the unloader would shut the pump off and just bring it down to just idling, essentially. So they call it pressure and flow compensated because while it's operating, it's pressure compensated. And then when you drop all of your levers, it also cuts the flow rate down on a lower pressure. The pump essentially shuts off down to idle. Well, that's what pressure compensated does anyway. It does, but at a higher pressure. Your system pressure is often 2,500 pounds. So there were 2 valves there. One was the unloader for standby pressure, as they like to call it, and the other one was your normal, everyday pressure compensation valve. When you pulled the lever, it send that 350 psi signal would come back, snap that loader shut with a spring, and there you are. It turned the pump on and go into pressure compensation mode. So in pressure compensation mode, the pump tries to go full stroke with everything it does. Everything. Bang. And when the pressure rises to that cutoff point, which on a 2,500 pound system would generally be someplace around 2,300 pounds, and sometimes even as low as 2,000, but usually when it's about 200 to 300 pounds away from the maximum, it'll start to back off a little bit, just as a natural course of the spring. has to compress to get to that point in the compensator, and it snapped. The pressure would build up high enough that the compensator would open up and shut the pump to minimum stroke. So that's basically how the system works. It's like a relief valve that doesn't relieve the tank, it relieves to the actuator to shut the pump off. Piston. Then there's a spring that's always trying to bring it to full. Now, on some other rare systems, the hydraulic pressure alone tries to put the pump to full stroke all the time against a spring that's trying to put it at neutral. So you have to study your systems to know which one you're working with. What was the one I had an oddball? Takeuchi. It was a Takeuchi TB260. Takeuchi Backhoe 260. Like a 26 ton or so. Cute little excavator, and it wasn't doing, he's operating and everything's working great, but then you go to travel and he buzzing along, everything's great. He starts putting the blade down and digging dirt, and it just died, went on its face and went to minimum stroke, which they never shut out to full neutral, to full zero. And he could push a hill down. Main pressure was there, because they call these pressure compensated, but they're truthfully not. The relief valve operates more often than that, but that does cut it down to kind of a small minimum flow. And he could push a hill over with that little thing, but take all day to do it. That one was spring loaded to full. That was pressure compensated to off, and which most are, but there's a few that have a different balancing system in the thing. And what I did was turn the spring pressure up without authorization that we were supposed to ask for, because I sat there for an hour and a half waiting for return authorization that was supposed to be immediate. So after 2 hours, I finally got down, turned the thing up until it ran well, and left. And the guy called me halfway back to the shop on my hour and a half trip. Told him what I did. He said, "Oh, good, because we've had that problem with him. I was supposed to get authorization. Oh, you called. We got the message. It's okay." So those are kind of some of the simple problems I've run into over the years. Komatsu, working on some of that stuff, that's a whole different explanation to get into. These are some of the simpler systems. Your old John Deere 1000 series, with that flow center system on theirs, that's strictly pressure compensated with a screwball charge pump system. They'll put a 9-gallon a minute main hydraulic pump up front, and they'll have a 6-gallon a minute charge pump, hoping you never use the 9 gallons. They just figure if you're running a loader or some other cylinder, that 9-gallon a minute will pull more than that charge pump can supply, and they have a connection that bypasses and pulls out of a reservoir somewhere when the charge pump can't supply enough. But they're planning on you pulling the lever, and man, look at that cylinder go, and it only goes for a couple seconds. Well, the lower part of the system can keep up with it. Later on, people found that they could get a 9-gallon a minute charge pump to put in most of those tractors with a 9-gallon a minute pump, or 12 with a 12, and suddenly they had a real working hydraulic system of sorts. And it still wasn't enough. The 9 main should have had a 12 charge pump to it, but it did improve it drastically. But it's pressure compensated with a relief and an unloader. A lot of your systems have hydraulic systems have an unloader on them that are just plain pressure compensated. And you said, "No, wait a minute, that's right. Remember I said standby pressure unloader puts it at minimum? Well, you start to crank the tractor over, the pump turns, and it'll come up to that unloader because there's no signal. It stops at 350 to 500 psi. So there's not a lot of parasitic load for the starter to worry about. Plus, you're talking about a starter that's 14 inches long, just the motor section, 12 to 14, monstrous truck starters on some of them that people put in. But in this case, you're talking a John Deere, as it's cranking over, the pump is pumping oil, but it's not at a particular flow rate. Okay, when it reaches a certain flow rate, now the unloader shuts and stays shut as long as that pump is turning, because it has pressure behind it. The flow actually starts to move the valve when it gets to a certain rate after the engine starts, snaps it shut. That's how they're able to crank these things and start them. You run into some of the John Deere tractors that you go to crank them and Arr, 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 arr. And then you go to turn the key and it goes, eh. What in the world? Take your steering and turn it. Then there's some guys that start the tractor up. They turn the key and turn the steering wheel at the same time. They're acting as an unloader, so to speak, through the steering system, taking the oil flow before it needs much pressure. Once you come to the end stops, now it's all over. Or if you get in the mud or something. So that's one of the tricks to that system. The pressure compensation has one adjustment, plus there's a relief, and all these systems that have a separate relief. Any pressure compensated system, PFC system, or closed center load sensing, they all have a separate relief that's set approximately 300 psi higher than, and the main relief higher than the compensated. Why? Because the pump's going to overshoot now and then, and they don't want that thing popping off unless it's needed, because the pump's going to be changing flow rate like this half the time, especially on excavators and some other equipment similar. So when the flow rate changes a lot, you'll get some spikes and peaks that can pop that little relief. Well, you start running 3,000, 3,500 pounds of relief, it gets hot. On some of the other machines, 5,000 and 6,000 psi, that'll get that oil hot in a rocket hurry. So that's why they have a relief 300 psi higher than your main relief. Sometimes you can get away with 2, but I know in White system they wanted 300 pounds, because I used to set them all. I used to set the compensator at 2,500, especially on a used pump. Sometimes I'd take it down even lower. If I was concerned about the pump being old, I'd back off the pressure to 2,200 or 2,300 pounds, and I'd set the relief by turning the pressure up on the compensator at 2,500 psi, and then I'd set the compensator 300 pounds less. And that would save sometimes the pump that was an old pump and working itself to death. So that's some of the stuff that you can do with those. Most of that will roll over from the Oliver systems into the John Deere systems, but they put everything in a different place. Oliver has a Vickers pump up here and their controls down here, so they can put any Vickers pump they want to that'll plumb in there. It doesn't matter. And it's about 15 gallons a minute. And the John Deere was someplace around 12 or 15, but theirs is a radial. All the pistons out in a cam. But they have the exact same controls in their systems, except one thing. The steering is direct in the hydraulic system. Oliver has a priority valve in the system to run the steering, to go from the steering for your brakes and your PTO. So it's a little different there, but not drastically. And that little control valve they have there, once you learn what's in there, just clean the thing up, make sure everything works, do your basic adjustments. And the priority valve is one of the easiest things in the world to do. They say, how does that work? And I said, well, back your compensator out. Start your tractor up with your pressure. You can put your pressure gauge in the back remotes. In fact, that's what I did. And you start your tractor up. And then when it gets up, to activate your remote and leave it locked there. And then back off the pressure compensator. And as the pressure goes down, you'll hear a funny sound. And the pressure will pretty much stop going down. But it can continue to go down. And then what you do is you turn it, but it usually stops at a particular point and then comes just a little slower. As soon as it stops, you have an idea what your pressure priority valve is. Okay? Let it drift a little bit, maybe even shut the tractor off. Just back it out a little more, turn the tractor off, fire it back up, watch the pressure go up. And when it does, it'll go up to a particular point. Well, actually, it won't go up at all. You've reset everything. Once it goes down to 0, now you're turning your compensator with your valve open up here. And I've done it with a 3-point hitch as well. You turn it up, put the 3-point hitch up, and you turn the compensator in. You can't have your remote on, just 3-point hitch. Lock the lever for raise, and just turn the compensator in the instant 3-point starts to raise. You check your pressure, especially out the remote. You can have that locked. And when it starts to raise, you can pop your remote, check the pressure there, because that'll have pressure. Your 3-point hitch will go all the way to the top, then shut off, and then you'll get your full reading here. And if you're anywhere around 1500 psi, you're golden. That's your set. But watching that 3-point hitch or watching your gauge on a remote when you start it back up, that can give you an idea. It's been decades since I've adjusted one, but that's how I remember that I put it in the remotes and I use the 3-point hitch to know when things were going to work. And I think one time I adjusted a priority valve once. They have an unloader in there too. It's under a little cap in there. So it's pretty simple system. I enjoyed working on the things. I enjoyed it immensely. It was tough to get in there sometimes, but I really enjoyed working on those Oliver systems. And the Allis-Chalmers systems, you just didn't. I mean, we had trouble. There was no doubt. Pumps went bad, etc., etc. But for the most part, the Allis-Chalmers hydraulics and the Ford hydraulics, if they didn't have a flow divider, like Ford had a manual flow divider on some of their 1000 series tractors, that was the biggest curse they ever had in them. But you could adjust it so your draft was slow when you're plowing, so it didn't make jerky moves. At the same time, nobody really cared. And they were hauling implements that are heavy enough, to take up the shock. Well, I figured I'd just do that. Now we're coming up on 42 minutes, and it's time for me to get outside. My shoulders have been in bad shape today when I woke up, so I had to wait for them to calm down. Now I'm going to go back out and start setting up trellis for my cucumbers. And then later on, yes, I've got a lot more shop work to do. TO20 Ferguson coming up and an engine for a VAC case. Now, unfortunately, they're all mine. They aren't paying. Out in the road, I'm trying to get a ignition module box for a Ford industrial engine. I've got a service on a Caterpillar skid steer. And later on, I'm working on a Maruka truck. I'm trying to get some of that thing back into shape. Catch you later.